Hello, welcome to STEM-tastic Wednesdays here at the McWanago Community Library. I'm Jacob, I'm the new innovator in residence here at the library. In this video, we are making homemade slushies. Now make sure you get your kit from the library. This kit includes 3 empty bags and 1 bag of table salt. Materials you will need are water, table salt, measuring cups, a small mixing bowl, 4 Ziploc sandwich bags, a freezer, gloves or a towel, 2 smoothie shakers or 32-ounce food containers with a lid, preferably translucent or transparent. We are using Gatorade bottles. Fruit juice, we are using orange juice. Make sure to not use a light version, and another optional item is soda or fruit-flavored syrup. Experiment, we will be making a special kind of ice which we will then turn into a slush. First, add a half cup of water into your mixing bowl. Add approximately 1 teaspoon of table salt. Then, optionally, add 1 or 2 drops of food coloring. This will give your special ice a nice color and make it easier to detect leach saltwater solution in your slushie. Now that that's mixed, we can pour the contents into a Ziploc bag. Once you've done that, make sure to close the bag and set it aside. Repeat the step 2 or 3 more times until you have 4 Ziploc bags of saltwater solution. Make sure to store the bags for at least 5 hours or overnight in the freezer. Make sure the bags do not touch each other so they do not freeze together. While that is happening, make sure to store at least 1 cup of juice and water in the refrigerator. Check if the 4 saltwater solution bags in the freezer are frozen. If not, wait a few hours longer before proceeding. If they are frozen, take the frozen bags of saltwater solution from the freezer using gloves or a towel to protect your hands. For each bag, open the zipper, push the air from the bags, and close the zipper again. Touch the bag with ice briefly with your fingers. If you have a thermometer, measure how cold the ice is. Ice cubes made of pure water are 0 degrees Celsius or 32 degrees Fahrenheit. Does the ice feel colder than the regular ice cubes? Did the thermometer confirm what you felt? Why would you need this special ice to prepare a slushie? Gather all the materials for the activity: juice and water at refrigerator temperature, the 4 bags of special ice, 2 shakers or food containers, and a measuring cup. Pour 1 cup of juice in the food container. Rinse the measuring cup and pour 1 cup of water in the other shaker or food container. Put 2 of the sealed Ziploc bags with frozen saltwater solution into each container before closing the lid. So now that we've done that, we can close the lid and shake 1 container a couple of times. Look through the sides of the container and then repeat with the other container. While you're doing that, something you want to look for is how do the liquids drop down from the sides of the container. Place your containers down and count slowly to 20 before repeating the previous steps. Do this for several minutes. Does the way the liquids drop from the sides of the container change? Why would this happen? Does it happen at the same time in both containers? Open the container after about 3 minutes. Do you see hints of slush? Do you see a similar amount in both containers? Close the containers and continue shaking intermittently. Once you see a thick mass sliding down the sides of a container, open the container again and look inside. Do you have a slushie? How did this special ice in the bags change? Why would it have changed? If the special bag of ice still has solid pieces of ice inside, you can close the container and continue shaking intermittently to make it a denser slushie. Why might it not be a good idea to continue if the special ice is melted? If the special ice is melted, take out the bags of salt water and set them aside. If salt water has leaked in your slushie, disregard the slushie, freeze the Ziploc bag with salt water solution after rinsing them, and try again. There is a possibility that the juice never turned into a slushie. If your juice did not freeze, refreeze the Ziploc bags with saltwater solution after rinsing them outside and dissolving an additional half teaspoon of salt in each. Why do you think your juice did not turn into a slushie? Do you think you can solve the problem by adding more salt to the saltwater solution in the bag? Why or why not? Pour the slushie contents into a glass. If you have diluted syrup or soda, pour some over the slushie made with just water, mix well, and drink. Drink your juice slushie as is. Is one slushie better than the other? If you would like to make more slushies later, freeze the Ziploc bags with saltwater solution after rinsing them. You can use them again. Once done, you can dispose of the salt water in the sink. What happened? Did the water turn into slush faster than juice? This is expected. Juice freezes at a lower temperature compared to water, so it needs to cool over a longer period before the ice crystals appear. Pure water freezes at 0 degrees Celsius or 32 degrees Fahrenheit. Dissolving particles in water makes it freeze at lower temperature. That is why the saltwater solution you made in this activity feels so cold when you took it out in the freezer. While making the slushie, it absorbed heat from the liquids in the container. This process melted the saltwater ice and cooled the liquids. Fruit juice is made of fruit sugars dissolved in water together with some other particles like vitamins and minerals. As fruit juice contains pure water with particles dissolved in it, it freezes at lower temperature than pure water. Most often, its freezing point is not as low as that of the salt water you created, so the frozen salt water could still freeze the juice, but it did so more slowly than it could freeze the water. Digging deeper, a slushie is a dense, ice-cold beverage that resembles the thickness of melting snow. Slushies can be made in two ways. You can flavor finely crushed ice, or you can alter the freezing process of flavored water so that loosely ice crystals form. Shaking the liquid will keep it at the freezing point does just that. The freezing point of a substance is the temperature at which the substance changes from a liquid to a solid. For pure water, H2O, this is 0 degrees Celsius or 32 degrees Fahrenheit. At this temperature, water particles start to stick together and form a lattice or crystalline hard structure. Dissolving salt in pure water lowers its freezing point. This happens because the salt particles are in the way, making it harder for the water particles to stick together. This phenomenon is called freezing point depression. Salt is not only the substance that lowers the freezing point of water, but it is a very effective one that is commonly available. Dissolving other particles like sugar has a similar but smaller effect. In general, the more particles that are floating around in a fixed volume of water, the lower its freezing point will be. For further explanation, find out if it is easier to fix. First, mix syrup in with the water and make a slushie of the mixture, or to mix in the syrup after you have created slush from the water alone. Why would this be the case? Which way tastes better? Try other juices. Which juice is easier to transform into a slushie? Find ways to make a larger slushie. Find out what happens if you mix more salt into the water to create the special ice. What is the coldest special ice you can make? Test and see what happens if you do not shake the containers while making the slush. Thank you so much for watching this STEMtastic Wednesday video. See you next one.